The two types of inequalities we've done this year are Chapter 1, we solved inequalities of one variable. And when we had one variable, we would solve for that variable, and we would put the answer on a number line in Chapter 1. We did that with ones that, like you see on the screen there, and we also did absolute value inequalities, where we had pigtail and skateboard graphs. Then in Chapter 2, we moved to two variable inequalities, like this, and when we did those, that became graphing and shading. Okay, so those are the two types of inequalities that we have done this year. We're going to do those two today, only we're going to do them with quadratics. So we're really not doing anything different, except we're going to do them with quadratics. And these two really aren't any different. We're just shading. This one is only in one dimensions. There's no height to it. And this graph over here with the x and the y-axis adds height to your shade. This is just an x-axis. And then this one is x and y, adds height to it. So we're going to do these two things with quadratics. All right, so first we're going to start with the ones that are a number line. How can you tell the difference? Well, you look and see how many letters are in the problem. This problem has one letter, x. So it's going to have one axis, x. That's how you can tell. And probably on a test, if the problem doesn't have a big chunk of graph paper on it, it's probably not a XY axis question. So we're going to solve this, and we're going to graph the solution on a number line. Solving a quadratic, you have three choices. You can either factor it using the monkey method. You can complete the square, which was our vertex method from 5-5, or you can use the quadratic formula, which was our 5-6. Well, you have to use one of those methods to solve this quadratic. Probably everything I give you definitely today, is factorable. So if you like the monkey method, you should be able to use that on every problem. Okay? I myself am a fan of the monkey method, so that's what I'm going to use. So we're going to factor this thing. The first two have to multiply to x squared. The last two have to multiply to negative 18. And the nose and the mouth have to combine to make negative 3. Okay, 6 and 3 is a good guess. We just have to make sure we get our negatives in the right spots. And I think we need to have a negative 6 and a positive 3. And when we do that, I think everything lines up so that we have first two lined up, the last two are correct, and the nose and the mouth are correct. After we have a correct factorization, we bust those things out of there and set them equal to 0. And we get our solutions of 6 and negative 3. Those are the points on our number line. That's where we go on the number line and put a dot. Okay? In this case, it's going to be a solid circle. Everybody understand, remember the difference between open and closed circles? Why they're closed and open? It's the same all the time, all through your math career. Solid dotted, solid open. There's really only one concept for all that. In Chapter 1, we only had one dot. One side was true, one side was false. When we have two dots, it's going to be more like our absolute value inequalities we did, where it was either a pigtail or skateboard. So it's either going to go true. Here, I've got them drawn here. It's either going to look like this, where you have true and then false and then true, or it's going to be your skateboard, where the outsides are false and the inside is true. They're going to alternate. True, false, true, or false, true, false. Yes?
Why don't we test 0?
We are going to test 0 to see which one it is. Whether it's true, false, true, or false, true, false. Good idea, Alex. So we put in 0, and we get negative 18 is greater than 0. And that's false. So the middle area is not true. Remember, the thing we're working with all year is what numbers can I put in to make this thing true? And that's what we're working on here. I want you to draw a picture of the true numbers. The inside is false, so the outside is true. So it's pigtail graph from negative 3 and 6. X squared plus 3x minus 28 is less than 0. I'm going to factor using the monkey method. First two, x squared, boom, x and x. Last two have to multiply to 28, negative 28. And this one's pretty easy because you don't have that many options with 28. What's it going to be?
7 and 4.
It's going to be some sort of combination of 7 and 4, giving me a 3, positive 3. So I'm going to want it to be positive 7 and negative 4. So my nose and my mouth add up to positive 3. I separate those out and set them equal to 0. And those are my critical points on my number line. Negative 7, positive 4. Find 0 on the number line. Open circles this time, remember, because it's just less than. Test 0. I get negative 28 is less than 0, which is true, which means that the middle is true and the outsides are false. So you have a skateboard, which means that you can test any of the numbers in here and they will be true. Any of the numbers out here, any of the numbers out here, if you test them, they will be false. Yes, ma'am.
So
I want you to work on this one. It's going to lead to a conundrum, and then we'll go over the conundrum once we get to it. But you start it on your own. Double root. Both sides are going to be the same. Test 0, 0. It's false. So the only answer that works is 2. All right, let's do one more, and then we'll move on to 2 dimensions. We have a factoring of x minus 7, x plus 1. Critical points, 7 and negative 1. 0 is false. And so I get a skateboard graph with open circles from negative 1 and 7.